Hello, Team PCH. So we are now into section 1.6. This video is only going to cover reflections and absolute values, and we will talk about even and odd in class. So I'm going to start off with the reflections, and I think it might be helpful to remember that whenever you see f of x, it's just another name of saying y. So when we are doing a reflection where the opposite of f of x, it means that you're taking whatever the y value is and you're making it negative. So if it was positive, it becomes negative. If it was negative, it becomes positive. What that means is this then is a vertical a vertical reflection over the x-axis. In other words, if your point was here, it would now come down here. If it was down here, it will now go up there. So it reflects you over the x-axis. It changes the y value, so that's going to be vertical. Then if you put that negative on the inside, you're taking the opposite of whatever x is. So that's considered a horizontal reflection. And since it's working horizontally, it's going to go over the y-axis. So that means that if your point is over here, it's going to move to over here, or if it was over here, if your x was negative, now it's going to go over here. All right? So that's how reflections would work. So let's take a look at a graph here. I find if your graph has actually distinct points, sometimes it's helpful to go in and identify those points. So this is negative 3, 4. This point is 1, negative 1. And then we have several points that have, let's see, this one is going to be 2, 4, and 4, 4. So then we can just reflect the points and kind of then do a nice solid line. So in this first one, if we are reflecting over the x-axis, that means we are doing the g of x equals the opposite of f of x. So we are doing a vertical sort of translation. As a rule, if you remember way back from geometry when we did our reflection rules, this is the same as keeping your x the same, but the y is now going to be the opposite of whatever it was. So instead of 3, negative 4, negative 3, 4, sorry, I'm now going to have negative 3, negative 4. I'm not going to actually label all the points because that just takes time. 1, negative 1 is now going to be up here at 1, 1. And my 2, 4, and 4, 4 are going to become 2, negative 4, and 4, negative 4. And then we can just fill in, connect the dots. There we go. So that would be a vertical reflection. If I want to do a horizontal reflection, so this one is going to be over the y-axis, then again, that rules g of x equals f of negative x, the x values, and as a rule, xy is now going to become the opposite of x, y. So we're going to take the opposite. So instead of negative 3, 4, it's now going to be a positive 3, 1, 2, 3, 4. The y value stays the same. And my 2, 4 becomes negative 2, 4, negative 4, 4. And now we have negative 1, negative 1. And we just then connect the dots. So it should look like it reflected over the y-axis. Okay? All right, so now let's move on to the absolute value transformations. And there's two types, and sometimes people get them confused with one another, but again, sorry about that, I just shrunk everything. Let's take a look at when you have the absolute value of the y value. So remember, think about that. F of x is your y value, and whatever that y value is, you're throwing it inside an absolute value. So that means nothing. There will be, when you are done, nothing will exist down here below the x-axis because all your y values have become positive. So when you're doing this, it leaves the x values unchanged. Values, what am I? I'm thinking and writing to, leaves x values unchanged. But all the y values, because remember that's what f of x represent, become positive. So if they're already positive, there's no change. Now it's really important that you show us that you understand the whole transformation. So if we give you a graph like this, what we want to see is so everything from here up stays exactly the same. And you actually want to show that. So you want to draw over it. Otherwise, you're telling us that that somehow went away. What we're now going to do is take each one of these y values and make them positive. So -1 becomes 1, -2 becomes 2, 3, etc. And that would represent now your new function, the absolute value of f of x. Now what if we want to take this parabola? So again, notice this part here is not going to change because the y values are already positive. But the branch down below, there should be nothing down here when we're done. So we're going to kind of, if you can, sometimes it's a little hard. I notice here at 4, -3. So that means I'll be at 4, 3. Try and find at least one point, and then you can draw your graph. So down here looks like I'm crossing at -3. So now I'm going to cross at 3 with sort of that parabolic. And again, I want to emphasize, if you don't also show that this middle part is also part of the transformation, you're keeping it positive, otherwise you're making it look like that went away. So the last one we're going to look at is if you're going to do a transformation where it's f of the absolute value of x. So the y values, to some extent, remain unchanged. You'll see in a minute why I say sometimes. And you're going to basically delete everything where x is negative, right? Because you're only going to be graphing a positive value of x, and then reflect the positive values over the y-axis. So the way this works, and again, you want to show both parts. So whatever x value you have, you're now going to make it positive. So all the positive x values stay the same. There's no change there. So you can just, so on this side, x is greater than 0. There's no change because that's all good to go. On this side, you want to represent, so here's where x is less than 0. So if I plug -1 into my function, that -1 is going to become f of 1. So wherever f of 1 is, that's now going to be over here. Basically what happens is you are going to mirror the positive side on the negative side, positive side of x on the negative side. And so since this is just a line, I'm going to then just continue my line. Since it does have an arrow that keeps going on the positive side, I can keep that arrow going on the negative side. All right, so it basically takes whatever's on the positive side, mirrors it or reflects it over onto the negative side. What that means is this part, so again over here where x is less than 0, that's all going to go away. So we keep whatever's on the positive side. Now, if I want to plug in -1, it's going to mirror whatever f of 1 was, because you're making that x value positive. What if I wanted to plug in a -6? There is, and so that would represent f of 6. Well, there is no f of 6. So you're only mirroring what exists on that positive side. This part of it is finito. So over here, what we have is it is limited by the domain on the positive side, the domain where x is greater than 0. Everything else just goes away. All right? So we will practice with that in class, and we will then also go over the even and odd functions then.